You want to have $200,000 in your account when you retire in 30 years. Your retirement account earns 8% interest. How much do you need to deposit each month to meet your retirement goal? So, the letter that we don't know in this formula is D. We're going to use this annuity formula, fill out all the information we do know except for D, and then we're going to jump over to Desmos to help us solve. So let's fill this in. So P sub n, that is the amount we're going for, the amount our goal is. So P sub n is 200,000. And that equals our D, which we don't know, our deposit each month. And then we have 1 plus our rate. Our rate is 8%, as a decimal is 0.08 over K. Now, since we're depositing each month, we can also assume safely that they are compounding each month, so that there are 12 months in that 1 year. Our exponent, the number of years, is our retirement in 30, with our compounds being 12 again. We're going to have a subtract 1 out here. So we have a parenthesis here, we have a parenthesis here, here, and here. So 2 sets. We're going to divide that by our rate again, the 0.08, and have that divided by our compound number, which is 12 compounds a year, and we can also put that in a set of parentheses. So a lot of parentheses here, but that makes it easier for Desmos to help us solve and easier for us to graph on Desmos. So what we want to do is put the left-hand side of our equation in a y equals, and separately put our right-hand side of the equation in a y equals, and then we're going to find out where they intersect. So that's our goal for Desmos on here. So let's jump over that and start. So we have y equals 200,000. Okay. Then we also have y equals. Now we aren't going to use D. We're going to actually use X in this case, but we do know that that's going to be our D. We have a double set of parentheses, 1 plus 0.08 divided by 12. Then we're going to use the right arrow to end our parenthesis there. Then we want an exponent, so shift 6. We have 30 times 12. Now I'm going to put my exponent in parentheses because whenever I don't, it always moves it back down for that 12 to be next to it instead of actually in the exponent. Now I want to move down and subtract my 1. We're going to end our parenthesis there, and then we want to divide by another set of parentheses, 0.08 divided by 12. Cursor to the right or right arrow, and then end our parentheses. Make sure that your equation matches up to the equation you see on your screen now. I think it's essential that we put the 30 and the 12 together in a set of parentheses instead of just the 12. I think that'll ensure that 30 times 12 are both in that exponent. So now what we want to do is we want to see where these two intersect. Now, what we can't see is y at 200,000. So we're going to have to open up our graph settings. We need our y-axis to go much further up. I'm going to say 210,000. All right, we see our blue line drifting off to the right, and the same with our red line that just showed up. So we need, and this is normal, to have our x-axis also moved to the right. So we need to change the max. So let's change to, I don't know, maybe 50. All right, 50 did not work, so because I still can't see where they connect, so let's change it to 500. Once I changed it to 500, I'm able to see where that intersection is. So I'm going to pull that intersection right to the center of my screen and click on it. And it says X equaling 134.19581 and 200,000. So what this essentially means is that the deposit needs to be $134.20, rounding properly for money, each month in order to have $200,000 by the end of 30 years. So let's jump back over to here and write that down. So how much do you need to deposit? Let me erase some of this red. And write this down. 134.20. Remember, we're going to round it. It's money, 2 decimal places. $134.20 needs to be deposited each month. All right, so hopefully this gives you an idea of what to look for in planning your own retirement.